Welcome to Lesson 3 of Module 4, Linear Equations in X. We have been using symbolic language to represent ideas so that they can be worked with mathematically. We've looked at equations that way. We've looked at expressions, and we've talked about what makes an expression linear as opposed to nonlinear. We saw that in Lesson 2. And in this lesson, we're going to talk about linear equations. So here are several linear equations. And what we're going to do is just take a brief look at these and come up with a definition of what is a linear equation. So you know what an equation is. You know what a linear expression is. So how could we describe a linear equation? Okay, well, think about that, and I'll come back in a second. And here is what linear equations are. They're statements about the equality of two linear expressions. Okay, so they're exactly that. They are two linear expressions set equal to one another. So in this example, x plus 11 is a linear expression, 15 is a linear expression, and I'm saying that x plus 11 is equal to 15. So on either side of the equal sign in all these cases are linear expressions, and they are connected by an equal sign. An expression alone does not have an equal sign. Okay, so another thing about linear equations is that they are questions asking, can you find all the numbers x that make the equation true? So it's kind of an invitation to find a value that will make this equation true. Okay, so equations can be true or false. They can be true or false. So, for instance, 6 plus 5 equals 16 would be false because the left side and the right side are not equal. The left side is 11, the right side is 16. Whereas the next one, 21 minus 6 equals 15, is true because the left and the right side are true, are equal to one another. And likewise, this one's true, and this one would be false. Okay, so we can think of equations as both true and or false. So look at this one. Here's an equation. Is this equation true or false? Okay, so this one's a little different. We can't really say whether this equation's true or false because it has a variable. So it could be true depending on what x is, could be false. Okay, so is there a value for the variable that will make this equation true? Okay, so it's with a simple equation like this, it's pretty easy to look at it, and some of us can look at it and say, well, this part needs to be 45 so that the whole sum can be 49. And if this term is going to be 45, then x would have to equal 3. If x is 3, then this is 4 plus 45. And the other side is 49, so it becomes 49 equals 49, which is a true statement. Okay, so we say x equals 3 is the solution to the equation because it makes the equation true. Okay, so when we put 3 in for the variable, then we get the left side, we get the left side of the equation equaling the right side when x equals 3. Okay, so, and that is a vocabulary word there, solution to the equation. It's the value for the variable that makes the equation true. Okay, so is x equals 5 a solution to this equation? Well, what we want to do is we want to work on the left side. We want to work on the left side and then the right side. So I'm going to just draw a line down here. So if I put in x equals 5 here, I get 8 times 5 minus 19. So 8 times 5 is 40, minus 19 is 21. If I work on the right side, I get negative 4 minus 7 times 5. So I get negative 4 minus 35. And I know that subtracting 35 is the same thing as adding a negative 35. So negative 4 plus negative 35 is negative 39. These are not equal. Therefore, x equals 5 is not a solution to this equation. Okay, so I could ask myself for this same equation, is x equal to 1 a solution to this equation? Well, let's work on the left side and the right side again. And here I get 8 times 1, which is 8, minus 19, which is equal to plus a negative 19. So I've got negative 19, positive 8, so I'm going to subtract and get 11. Let's go back to purple. I'm going to get 11, and it's going to be a negative 11 because negative 19 is bigger. Okay, and then over here I get negative 4 minus 7 times 1, which is the same as adding a negative 7. And negative 4 plus negative 7 is negative 11. The left and the right side are equal to each other, so x equals 1 is a solution to that equation. Okay. All right, so here's another linear equation. Okay, this equation's a little more complicated. It has more terms on the right side of the equation. So it is possible to simplify equations before going about solving them. So we'll simplify this one. We are going to, in this case, just go ahead and leave the left-hand side of the equation alone. We're going to simplify this side over here. So I've noticed that I have subtraction there. I'd like to have everything be addition because then I can move terms around, which is what I want to do right now. I want to get these two x terms together. So I'm going to call this 4x plus 7x plus negative 7. And I can do that because of the commutative property for addition, which tells me I can add these things in any order. And I'm going to work first on this 4x plus 7x. So both of those have an x in them. So I can rewrite this as 4 plus 7x, and I still have plus a negative 7. And I still have this over here. So I've used the distributive property because the distributive property allows me to factor out a common factor. And you're used to using it this way, taking this x, and usually it's out front. Usually we see this multiplier out in front of the parentheses, but it doesn't really matter, does it? Because I'm going to take this x and multiply it by everything in here. I'm going to distribute it that way. So it'd be x times 7, which is my 7x, and x times 4, which is my 4x. So this allows me to put these two together. And now that I have it like this, I can write it as 11x plus -7 over here, and 3 times x plus 9. Okay, so if I want to find solutions to this equation or check solutions to this equation, then I can use this version just as easily as this version. Well, actually, more easily, because this one is more, the one at the bottom is simpler, so it's going to be more simple to check solutions. Okay, move on. All right, so here's the simplified version of that equation, and I'm going to use that to determine if x equals 5/4 is a solution. So I need to put in 5/4 everywhere that I see an x. So this would be 3 times 5/4 plus 9, which is 36/4. I'm going to be adding those together, so I need a common denominator. And then over here, I'm going to have 11 times 5/4, whoops, 5/4 minus 7. All right, so I've got 3 times, and I'm going to add the numerators, so this would be 41/4. And let's work down the right hand side now. 3 times 41/4 is 123/4. Okay, whereas over on this side I have now 11 times 5/4, which is 55/4, minus 7, which I'm going to rewrite as 4 times 7 is 28, so I can rewrite that as 28/4. And when I subtract, I'll get 27/4 over here. So these are clearly not equal, so x equals 5/4 is not a solution. And I can write that it is not a solution to that equation. Okay, so we're asked here to transform this equation to make it simpler. All right, so I'm going to I keep doing that. I'm going to work on the left and right side separately to transform this equation and make it simpler. So I'm not solving this equation. I'm going to be checking this equation for a solution. I'm not quite solving it yet. We'll get to that in the next lesson, the next couple of lessons. But I want to move the terms around using the commutative property and combine terms using distributive property. So this negative 5x, I'm going to think of, or the subtraction of 5x, I should say, is addition of a negative 5x term. And same thing over here, I have plus a negative 6x. So what I'm going to do is I'm going to write this as negative 2x plus negative 5x plus 11. And then I can write this again, just like we did before, negative 2 plus negative 5 times x. and this becomes negative 7x plus 11 on this side. And my new equation says that that is equal to negative 6x plus 5 on the other side. So there's a version of the transformed equation. Those terms could be written in any order, but this works. Okay, so we're being asked, is x equals 6 a solution to this transformed equation? Now, they do have it in a slightly different form than we left it in before, but that's okay. So we're going to check the left side and the right side to see if, when I put 6 in for the variable, if these are if it's a true equation. So we've got negative 7 times 6 plus 11, and negative 7 times 6 is negative 42 plus 11, so this becomes negative 31. Okay, so we're going to check the other side, the right side, and over here we're going to have 5 minus 6 times 6, or 5 minus 36, and 5 minus 36 is 5 plus a negative 36. So we know this answer is going to be negative. I'm going to subtract the two numbers to cancel out some of those positives, and it is true that x equals 6 makes this equation true. So x equals 6 is a solution to this equation. Okay, now you have these exercises in your classwork, in your notebooks. So you can work independently on all 6 exercises, or you can do them one at a time with me. But it would be best if you would try them first, struggle with them a little bit, and then come back and check your answer. I'm going to go through these fairly quickly because this is the lesson we did in class. But I will talk about each one as we come to it. Okay, so go ahead and pause and work on those. Come back and check your work. Okay, here's my result for exercise 1. I put in negative 3 everywhere there was an x, and I evaluated the right side, the left-hand side and the right-hand side separately, and found that they're both equal to negative 13 when you put a negative 3 in. Therefore, x equals negative 3 is a solution to the equation, and the reason for that is because the left side equals the right side when I evaluated it. So that's the explained part right here. That's really all you need to say. And one thing that some of you might have done before you evaluated it is to take that part of the equation and transform it into 7x plus 8. But you would still get the same thing. You would just go straight to this negative 21 plus 8 stage. So save yourself a little bit of work. Okay. So I'm going to go on to number 2 now. If you haven't tried it, you should pause the video and try it on your own. Okay, here's my work for number 2. I have taken x equals 12 and put it in anywhere I see the variable. So that would be here and here. And I went ahead and used order of operations to evaluate each expression. The left-hand side, 16 minus 1/2 times 12. And I'm going to evaluate the 1/2 times 12 first because it's multiplication, of course. So 1/2 times 12 is 6, and 16 minus 6 is 10. Okay, so then over here I've got 3/4 times 12 for my x plus 1. So I want to do the multiplication first. I find common factors here that I can cancel out a 4. So it leaves a factor of 3 up in the numerator. 3 times 3 is 9, plus 1 is 10. So because the left side is equal to the right side, I'm going to say yes, x equals 12 is a solution because 10 equals 10, because I came up with that. Okay. Here's number 3. Chad solved the equation. It's a big equation. Is claiming that x equals 2 makes the equation true. Is Chad correct? Explain. Okay, so work on that, and then I will show you my solution to it. Okay, so for this exercise, the original equation is up here. I decided to take the left side and use the distributive property to write 24x plus 2x as 26x. So this becomes 26x plus 4, and when I put in 2, we're checking x equals 2 for this equation. So I put 2 in, I get 56 when I evaluate it. Whereas on this side, when we put 2 in, we get 57. Okay, so since 56 does not equal 57, the left side and the right side are not equal. This is not a true equation for x equals 2. So x equals 2 is not a solution to this equation. Okay, now work on number 4 and come back and check your work. All right, here's my work for this. This one ends up being a solution. The equation is here, and I'm going to check the left side, check the right side, and see if they're the same. So I put in negative 1/3 for x. 6 plus negative 1/3 is the same as 6 minus 1/3 or 5 2/3. Written as an improper fraction, that's 17/3. So either one of those numbers. Then over here, 8 plus 7x, put in negative 1/3 for x. And this is 24 plus, 24 thirds. I changed 8 into thirds. 24 thirds plus negative 7 thirds. So to do that fraction addition, I'm going to take 24 plus negative 7, get 17 thirds. So we can see that it is a solution since the left side and the right side are the same when evaluated. Okay, we're going to look at number 5 now. So if you haven't tried it yet, pause the video and look at it before you come back and check your work against mine. Okay, so for number 5, let's just say right off the bat that Angel is incorrect. He has made a mistake in transforming this equation. He ended up with an equation where the left side is 10, and it was 6x plus 4 minus x. So he's gotten rid of the variable. Maybe he thought something about adding 6 and 4 to get 10. Not sure how he made his mistake, but it doesn't work because x equals 4 is a solution to this equation. If I put 4 in for x, 4 plus 1 is 5 times 2 is 10. But the original equation, if he did this transformation properly, it would also be a solution to the original equation, and it isn't, because if I put in x equals 4 for the left side here, I get 6 times 4 plus 4 minus 4, which is equal to 24 plus 4 minus 4, which is just equal to 24. And the right side of this equation, 2 times x plus 1, is of course 10, because it's 2 times 4 plus 1. 2 times 5 is 10. And 24 does not equal 10. Therefore, x equals 4 is not a solution to that equation. So what this exercise kind of shows you is that if you transform an equation incorrectly, even though you get the right equation, the right solution to that equation, it won't be a solution to your original equation. So you need to do the transforming step carefully so that you don't come up with wrong solutions. Okay. Okay, let's look at number 6. I really like this problem. Claire was able to verify that x equals 3 was a solution to her teacher's linear equation, but the equation got erased from the board. What might the equation have been? Identify as many equations as you can with a solution of x equals 3. Well, there's a lot of possibilities for this, and students in class came up with some really creative things. So I'm going to just put a few here. I could have something really simple like x plus 2 equals 5. Or I could do something like, so I added something to x in that case, but what if I multiplied? 3 times x would equal 9 if x is 3. What if I had 5 out here? 5x equals 15. Those are also equations that are true. Someone in class even wrote this, x equals x. Does 3 work in that equation? 3 equals 3, it does. So 3 works in all of these. 3 plus 2 is 5. 3 times 3 is 9, so x equals 3 is a solution here. 5 times 3 is 15, so x equals 3 is a solution here. And 3 equals 3, so 3 is a solution here. Actually, anything would be a solution here, wouldn't it? And this is kind of a special case of an equation. So there are lots and lots of equations that are going to have a solution of x equals 3. So see what other ones you can find. Okay, number 7 here is also an interesting question. Does an equation always have a solution? Could you come up with an equation that does not have a solution? Okay, so all of the equations that we have looked at so far did have solutions. But we are going to find out down the road, by lesson 6, I believe, that there are equations that don't have solutions. And in class, we talked about this, and somebody came up with this equation. They wrote x equals x plus 1. Could you find some number, x, where if you put it in here and here, the left and right side would be equal? Okay, well, some people say, well, that's not even an equation, but it does fit the definition of an equation. This is an expression, this is an expression, and it's a statement of equality of those two expressions. Problem is, this really has no solution. So it's always false. X equals x plus 1 is always a false statement. But it is an equation, and it is an equation that does not have a solution. So, good job. And we'll be talking more about these types of equations and the different ways that, the different types of solutions that equations can have. Okay, all right, good luck with the problem set on this one. Just in closing, kind of some of the things we talked about and we stated up front. We know that equations are statements about equality, and this is also in your problem set. They're statements about equality to show that a number is a solution to an equation. We are going to evaluate the left side and the right side if they're equal when we replace the variable with the value that we're checking. If they're equal, then that is a solution. Otherwise, it's not a solution. Okay, I think you're good here, and we'll be back with lesson 4.